This is practice exam 3, question number 19. How many valence electrons are present in a neutral atom of bromine? From the previous question, question number 18, we already learned that actually there are a total of 35 electrons for bromine. Of course, those 35, most of those electrons will be the core electrons, and then there are a few should be the valence electrons, which means the outermost electrons. Okay, let's copy the electron configuration from the previous question. That's also for bromine. So for question number 18, let me use this shorthand notation to save some time. And then we'll have 4s2, 3d10, and 4p5. As I already mentioned, of course, everything here within this shorthand notation, they are all core electrons. So, but here you see the 3d10, because there are 5 3d orbitals, and the maximum can accommodate 10 electrons, which means this 3d subshell is fully filled. So therefore, that should be also considered as the part of a core electron. So therefore, the outermost, you just pay attention to the highest n value available. So in this case, it's n equals 4, okay? The s and the p, those two orbitals, 4s and 4p orbitals, pay attention to those, then count the number of electrons in those orbitals. That's 2. That's 5. 2 plus 5, that should be 7, which is this one. Okay. So in the lecture, we are also going to actually to go through this. In short, the number of valence electrons for main group elements equal their group number. Let's say the valence electrons for group 1a should be just 1. And their electron configuration is ns1. Either 1s1, 2s1, 3s1, that's ns1. All right? Group 2a is 2 valence electrons. And their configuration is ns2. You see? ns2. And same thing with 3a. 3a family or a column. So that should be 3. Why 3? You have 1p electrons. Then those 2 s electrons, they are also outermost. Okay? So, yeah. Therefore, if we look at bromine, so bromine should be actually in this position. So 35 atomic number and also 35 electrons. So for the atom, and that's why you see it's in the 7a. That's also why it should have 7 valence electrons. Okay, yeah. Really, the easiest way is as long as they are the main group elements, located their location, just see what is the main group number. So, okay, if it's 7, then that's 7 valence electrons. If it's 4, that will be 4. Okay, if it's 1, then that should be just 1 valence electron. So that's it's good to know that.